In 1977, humanity launched 2 silent machines into the darkness of space. No one expected them to survive this long. No one imagined they would rewrite everything we thought we knew about the solar system. They were called Voyager 1 and Voyager 2. At first, they were just robotic explorers sent to photograph distant planets. But over time, they became something far greater. Witnesses to alien storms. Messengers carrying Earth into the unknown. And reminders of how small we truly are in the cosmic ocean. As the Voyagers traveled farther from the Sun, they revealed worlds more violent, mysterious, and beautiful than anyone had imagined. Jupiter was not calm. Saturn was not simple. The icy moons were not dead. And somewhere beyond the planets, the probes eventually turned around and captured one image that changed humanity forever. A tiny pale dot floating in a beam of sunlight. Earth. Our entire civilization reduced to a fragile speck suspended in infinite darkness. But the story of Voyager begins long before that image. It begins with a once-in-a-lifetime alignment hidden inside the motion of the planets themselves. In the late 1970s, something extraordinary happened. Jupiter, Saturn, Uranus, and Neptune aligned in a rare configuration that only occurs about once every 176 years. For scientists at NASA, it was an unbelievable opportunity. Using the gravity of each giant planet like a slingshot, a spacecraft could leap from one world to the next, traveling deeper into space without impossible amounts of fuel. It was called the Grand Tour. Humanity had never attempted anything so ambitious. Voyager 2 launched first on August 20, 1977. Voyager 1 followed shortly after on September 5, taking a faster path that would eventually allow it to overtake its twin. Together, they carried cameras, scientific instruments, and a mission unlike anything ever attempted before. Not merely to observe distant planets from afar, but to enter their realms directly. And almost immediately, something about the mission already felt emotional. Shortly after launch, Voyager turned its camera backward toward Earth and the Moon. The image was simple, quiet, almost haunting. 2 small worlds drifting together in blackness. It was the beginning of a journey that would slowly reveal how isolated our home really is. Before Voyager, the outer solar system was mostly mystery. Astronomers had blurry telescope images and mathematical theories, but they lacked intimacy. The giant planets were distant lights. Their moons were barely understood. The solar system still felt incomplete. Voyager changed that forever. When Voyager 1 arrived at Jupiter in 1979, humanity saw the gas giant properly for the first time. And what appeared on the screens shocked scientists. Jupiter was alive. Its atmosphere churned with enormous storms and violent turbulence. Massive cloud bands twisted around the planet at incredible speeds. Lightning flashed inside gigantic storm systems larger than Earth itself. And at the center of it all was the Great Red Spot. A colossal hurricane that had been raging for centuries. But even Jupiter itself was not the mission's greatest surprise. That honor belonged to Io. Before Voyager, scientists believed most moons in the outer solar system would be cold, ancient, and inactive. Instead, Voyager discovered erupting volcanoes on Io. Actual volcanic plumes exploding hundreds of kilometers into space. It was the first time active volcanism had ever been observed beyond Earth. The discovery completely changed planetary science. Suddenly, moons were no longer lifeless companions orbiting larger planets. They were worlds with their own histories, their own internal heat, and their own mysteries. Then came Europa. Its icy surface was covered in enormous cracks and strange patterns unlike anything seen before. Beneath that frozen shell, scientists began suspecting something incredible. A hidden ocean. An entire sea trapped below ice in deep darkness. That possibility transformed Europa into one of the most important worlds in the solar system almost overnight. Voyager had arrived expecting frozen rocks. Instead, it found volcanic hellscapes and oceans hidden beneath ice. The outer solar system no longer looked dead. It looked alive. After Jupiter came Saturn. For centuries, Saturn had appeared elegant and peaceful through telescopes on Earth. Its rings looked smooth and perfectly symmetrical. Almost unreal. But Voyager revealed a completely different reality. The rings were unbelievably complex. Instead of a few simple bands, they were made of thousands of thin ringlets, tangled structures, gaps, waves, and braided patterns stretching across enormous distances. Some sections looked twisted. Others appeared broken apart. Strange spoke-like shadows moved across the rings in ways scientists did not fully understand. The closer Voyager looked, the stranger Saturn became. Then its moons began revealing their own secrets. Titan emerged as one of the most mysterious objects ever discovered. Wrapped in a thick orange atmosphere rich in nitrogen, it looked less like a moon and more like an alien planet. Nothing beneath the haze could be clearly seen. That elsewhere, Enceladus hinted at geological activity that later missions would confirm as enormous icy eruptions blasting into space. Everywhere Voyager traveled, complexity appeared where simplicity had once been expected. The solar system was transforming from a collection of distant spheres into a living system of active worlds. After Saturn, Voyager 1's primary planetary mission ended. Gravity hurled it upward and outward toward interstellar space. But Voyager 2 continued alone. Its next destination was Uranus. Even today, Uranus feels strange compared to the other planets. Voyager revealed a world tilted sideways, rotating almost horizontally as it traveled around the Sun. Its magnetic field was equally bizarre, wildly offset from the planet's center and tilted at impossible-looking angles. Scientists had never seen anything like it. The moons were even stranger. Miranda looked shattered and rebuilt. Gigantic cliffs cut across its surface. Canyons and fractured terrain suggested catastrophic forces from the distant past. It looked less like a normal moon and more like the remains of a broken world stitched together again. Then came the final planetary encounter. Neptune. At the edge of the solar system, scientists expected calmness and silence. Instead, Voyager discovered chaos. Neptune's winds screamed through its atmosphere at incredible speeds, becoming some of the fastest winds ever measured anywhere in the solar system. Dark storms rotated through the blue atmosphere like giant shadows. And orbiting Neptune was Triton. One of the coldest places ever visited by a spacecraft. Yet somehow, it was active. Voyager observed dark plumes erupting from the frozen surface. Geyser-like activity on a world so cold it should have been frozen solid. Again and again, Voyager forced humanity to confront the same truth. The universe was far stranger than expected. But perhaps Voyager's greatest achievement was not what it revealed about planets. It was what it revealed about moons. Before the mission, moons were often treated like secondary objects. Interesting, perhaps, but unimportant compared to planets themselves. Voyager destroyed that idea completely. Io erupted with volcanoes. Europa hinted at oceans. Titan hid beneath thick atmospheric haze. Miranda appeared torn apart and rebuilt. Triton erupted despite existing in deep freeze. These were not lifeless rocks. They were worlds. Entire environments with geology, chemistry, weather, and histories stretching billions of years into the past. Voyager transformed humanity's understanding of the solar system from something static into something alive. And then came the image that changed everything. Years after the planetary encounters, Voyager turned its camera back toward Earth one final time. The spacecraft was billions of kilometers away by then. Earth was almost invisible. What Voyager captured became known as the pale blue dot. In the image, Earth appears as a tiny speck suspended inside a ray of sunlight. Almost nothing. A fraction of a pixel in endless darkness. Yet everything humanity has ever known existed there. Every civilization. Every war. Every dream. Every human being who ever lived. All contained on a tiny point of light nearly swallowed by the cosmos. The image was more than photography. It was perspective. For the first time, humanity saw itself from the edge of the solar system. And suddenly, Earth looked fragile. Voyager's mission no longer felt only scientific. It felt philosophical. The probes had traveled across billions of kilometers revealing storms, rings, volcanic moons, frozen oceans, and alien skies, only to show us that home itself might be the rarest thing of all. Most space missions are remembered because they ended. Voyager became legendary because it kept going. Long after the planetary flybys were complete, both probes continued outward toward the boundary of the Sun's influence. The solar wind weakened. The environment grew quieter and stranger. Then history was made. Voyager 1 entered interstellar space. Later, Voyager 2 followed. Humanity had officially crossed into the space between stars. What makes this achievement feel almost unreal is the age of the spacecraft themselves. These machines were built in the 1970s. Long before modern computers, smartphones, or the internet existed. And yet decades later, they still whisper back